now we can get started. Today we're going to talk about stacks and queues. Did we ever cover this in OOP, Java?
Slightly.
Good. So hopefully this is a review, in which case today will be easy. If it's not a review, make sure you stop me. But we're going to go over stacks and queues, and the lab is literally implement a stack or queue. There's an easy way and a hard way to do this. Hopefully everyone will choose the easy. Oh, that's a lot of objectives. All right, a stack. So a stack is a data structure in which elements are added and removed from one end only. Literally, it's like a stack of plates. So deletion occur at the top of the stack, so it's literally a LIFO, last in, first out data structure.
Accounting principles.
Accounting principles. So it's best to, you can literally think of this as a stack, like a stack of plates.
Or stack of pancakes.
Or a stack of pancakes, all right.
That just makes me hungry.
I don't know how to draw a pancake.
Same way as a plate?
You just say it's a pancake instead of a
Circle?
plate.
Just draw a thing, a bunch of boxes.
Stack of boxes, there we go.
Stack of boxes. Because in computer science, we only know how to do boxes and arrows.
Yeah.
So, add, I don't know, 5. Oop, oop. Here's a 5. And actually, it's not add. Wow, that's terrible. It's push.
Push. Right.
Push 5.
Top
Pushes
is
on.
right.
And then you can push. What should we push next?
12.
69.
12 it is.
You don't have semicolons.
I also don't have the object in front, so this code's totally messed up. That's okay.
Well,
Also, this
totally
this rectangle is kind of.
Your stack is going to fall over.
I think so. We're gonna have to fix this. Let's go ahead and push one other number.
15.
15.
Why?
Ew.
Yeah, the 15 made up for it.
It's
Well-
a slightly triangular box.
That is really far. That's a big space in between them.
Oh yeah, it looks like it's a 1, 5. Is that better?
Yeah, that's better.
Okay, good.
We're picky people.
I've noticed. So if I pop, what should I get back?
15.
5.
15.
15.
Last in, first out. Yeah. So 15 was in there last, so it gets back to 15. 15 goes away. I can push 25.
25 is up there.
25 goes back up. Now if I pop, I get
25.
25.
Woo.
Man, we're
Doing
doing
great.
awesome.
This is easy.
Thank you. If I pop again,
Now.
12. Well,
all right.
What?
Whoa.
where's the easy button?
If I pop again, am I getting off the?
5.
5.
5.
All right.
Oh no, I see where this is going.
What am I going to do next, Caitlin?
Ah,
Oh, yeah.
Pop nothing.
Null.
void.
What do I get?
Not void.
Null.
Error.
You broke it.
We'll just write a sad face.
Okay.
Oh, it's great. Sweet.
What would the compiler
Oh,
do?
you are just on the screen.
Just barely.
Man, that was awesome. That was perfect.
Perfect.
Good job, guys. Any?
Wait, what if you actually pop there's nothing there?
It depends on how your implementation is.
It depends.
It always
We use that in linear algebra, but we say not necessarily.
Not necessarily.
Mm-hmm.
Hmm.
She says not. It depends, but ours is not necessarily. and
Not
that's-
necessarily. I prefer it depends.
Yeah.
Or undefined. The behavior is undefined.
Sure.
All right. You push and you pop. Wow, that's beautiful. Look, we have stack
Whoa,
of.
there's actual real pictures.
I know, right? They're even colored.
Shoebox.
That's awesome.
We
It's
tried
just
to.
stack boxes. Read.
So, any comments about the color scheme?
I
I don't like the yellow.
don't like the stack of boxes or the yellow.
I don't like the stack of trays.
I don't like the fact that the green has a red lid.
That's
I didn't
true.
even notice that.
Wow, that is weird. Well, no, it's a Christmas box.
No. The Christmas box would be red with the green lid.
Yeah. I
Any
feel
other
like
questions?
that's a better combination. Or you have like red accents in the box, then it'd be okay.
You asked.
No, I did. That's why I did it. So an empty stack's on the right. Pushing A, B, C, peaking. Oh, we didn't talk about peak.
Oh,
We
So-
talked about peak last semester.
Yeah, so peak just looks at the top.
yeah.
It doesn't actually pop it. And then you can push D, and then you pop, you're back to that data structure. Good morning.
No, I remember.
All right. So notice how this is done. It's a little different. You initialize the stack. You can ask if it's empty, ask if it's full. You push something. You top, which is peek, gets the top item, and then pop doesn't return the top item. It just removes it.
So top is peak from Java.
Mm-hmm.
Okay.
Is full stack?
Is full stack. Is the stack full?
How can you know if it's full or not?
How can it be full? Can't you just keep adding stuff?
Well, it depends on how you implement it, right?
Gotta love OOP.
So, implementation of stack as arrays. First element goes in the first array, second, so forth and so on. The top stack is the last one. Stack elements are stored in an array, which is random access. So, stack element is accessed only through the top. To track the top position, we use a variable stack top.
Stack top. No,
Yeah.
Lovely.
Lovely stack top.
Ow.
So you can dynamically allocate the storage, which enables user to specify the size of the array. Great. And let's see, stack type implements function. Right. Okay, that's nice.
Next.
Right. So that still has initialize empty, is full, push top, pop. Right now they also have a copy stack internally, the stack type, and then a destructor. Why do we need a destructor?
Because we need it.
Because we need to. Yeah. What memory is being used?
Alright.
Yeah, the array. So we have to free the array. So C++ arrays begin at index 0, in case you didn't know.
What?
Boom!
No way.
So if you're keeping track of the top, and you say the top is 0, we're going to say the stack is empty. If the top is non-zero, it's not empty. Anyone have a question about that?
No, not really.
Where'd that notice go? Top element is given by stack top minus 1. All right, so for example, if our stack object contained a max size of 100, because our array size is 100, and the stack top is 4, aka up there, and the list points to the beginning of the array down here, then that means that the stack has A, B, C, D. 4 elements, aka top is pointing to element 4 right here, which is empty. Everyone good with this picture?
Sure.
Okay, next one question.
Oh, yes?
I'm just clarifying. So the stack can have a specific size, so we can check the full stack because it's using an array?
Yes, if you use an array to implement a stack, you have a full size.
Okay.
But if you use like list units,
Then
any size.
any size. Oh, that'd be nice.
Whatever you want.
No, that's not always good. As we found out, I break things.
All right. So initializing this. Wait, what's the difference here? Oh, initialize stack. So if you initialize the stack, that just makes the stack top down to 0. So how many elements are in this stack? This can be a trick question. How many?
0.
0. Even though A, B, C, D is in the memory, we're saying there's 0 because stack top 0. What?
Because the stack top 0.
Right. So the stack top's down
Wait a
here.
minute. What if the top of your element, top of your stack was the actual value 0?
Mm-hmm. That's fine. I mean, you can
But-
push. If you push 4 zeros on the stack size is still 4. They just each element contains 0.
I know, but I guess because you said like if it's empty, stack top will be 0. So wouldn't that get a little confusing or no?
Is stack top like the index?
Let's start drawing more pictures. I like pictures. We have this, so let's stick with this. I already wrote that. I don't want to write it again.
Okay. Oh no.
Let's go over here.
That works.
Excuse me.
Yes, you-
All right, I'm good now.
Why did you walk all the way over there? Just
I don't know, so it's not off the screen. Oh, that's beautiful. Okay.
I'll accept that one.
You'll accept that one. So here's our stack object. And we have
It does look like a box cutter.
what?
It's a box cutter.
Inline's 100. And stack top equals, what does it equal when we start?
0.
0.
Sure.
And then the M array goes to here. And let's go divide some elements out.
Oh my gosh.
All right. So right here, we're pushing 5. What happens?
5 goes in the bottom.
Going over the edges.
Yeah, I noticed that. It's okay. It's gonna be okay. All right, we're gonna be okay.
It's hard though. The OCD is real.
Put 5 right here. Do we do anything else?
No.
We do one other thing. What do we need to do?
Update stack top.
2.
1.
One.
There we
Plus plus.
Oh, okay.
go. All right. So now we're over here.
You
Okay.
put 12,
All right.
and you add 1 to the stack top.
Okay.
Wait,
And it's
so
the same thing with 15, so you could just put 3.
Hold on.
is,
One step at a time.
is stack top just a counter then? Sort
Yeah.
of?
Yeah.
It's just
Okay, I thought it
Stack
Because
top.
technically, right now, stack top points to this.
It shows
right?
the next index.
Oh, wrong. Wow, that was a terrible error.
No.
There we go.
Oh gosh.
Okay.
The arrow had an issue.
The arrow had an issue because really, when you go to push the 15, you go to M array sub in stack top, put the 15 there, right?
Okay.
And then you increment stack top, so now it's pointing over here.
Okay. I
Okay.
thought that's why I was asking about the 0 because I thought that the stack top was just like push, like pointing and returning like the value of the top of the stack, not the just like kind of the location. or
It's
the
keeping
number
track of the
stack.
top of it. Yeah, what's the
Yeah,
next top?
I thought it was like
What's
keeping track
the
of the
next
value inside of it.
So,
Basically.
yeah, exactly. What's the next
Yeah.
index? All right, so if we top and we have this, what number should we get back? Loud and proud?
15.
15. All right.
Oh.
Yeah, because
Oh,
remember our
okay, yeah,
pops
that's the
don't do what
function
we
on this
did
side.
originally, which is fine. Okay, so top is 15. And now we're going to pop. What do we do next?
You take the 15 and you change stack.
You don't do anything to the 15. You do one thing.
Oh, you just change the stack top to 2.
What? What?
That's all you have to do. Right? I mean, the 15's there, but it's not. It's now deallocated. It's now deallocated. There we go. It's been deallocated.
So, whenever you like push something, it'll just override that spot.
Yeah, you know, like this next stop, what happens?
You put
Push 25 in
inside.
that spot and then
Yep.
you increment the stack top.
Hmm?
I love your arrows.
There's a dot. You missed a dot.
I'm glad I can appease you.
You missed a dot.
So does stack top like correlate with the index of the
Oh
array?
no.
Yes. It's the next empty index of the array in this example. What? There's a dot? Really?
And now it just
Get
moves
rid of the 20.
stack.
Hold on. Any questions up to this point?
No.
No.
All right. So now we
Now we pop the 25 and we make the.
we don't do anything in 25. We only
Deallocate.
we don't right, deallocate it by. We just change stack top.
Yes.
We cheat.
It's not cheating. This is what you do.
Wait. Isn't the 25 still be in memory then?
That's fine.
Which is why you
Why?
need to
Wait,
do the
why?
deleting.
Why not just delete it?
Why would we delete it?
Because it takes up less memory?
No.
No, because then you
Are we
have
creating it on
if you're in
the stack?
delete, you're going to delete the whole array. You don't delete just a memory cell. So you just leave it because it's already
Which
taken up
is
the
why
space.
You need, I guess, is that why you need to delete the array at the end?
Yes.
I want to say deconstructor.
You can say the deconstructor.
Okay.
I'm okay
That's
with
why
it.
you need the deconstructor, because you need it to get rid of all of that. Because if you pop everything,
Right.
it's still there, but it's not being used, and it's not being pointed to or anything. It's just kind of memory.
Can
Number.
it get more tricky though? Say if we needed to pop some more numbers, how would we go around the 25 then?
What do you mean?
Just pop and move this stack top.
Well,
to the-
remember I already had the example where I pushed 15, popped that 15, and then overrode it with 25.
Okay.
Okay, if we pop again, what do we do?
Change
You
stack
move
top to
stack top
1.
down.
All right.
Magic.
So it goes to
Goes to 1.
Not magic, science.
It's science. All right, hold on. Someone besides Caitlin, Sydney, or Craig.
Aww.
What happens on this pop?
goes down to
Stack.
5.
Stack
Goes to 0.
goes to 0. There we go. Making sure everyone's on board.
Look, we can count.
Yeah,
We can count.
3.
All right. Now, ooh, here we go. What happens here?
Sadness.
Sadness. An error.
Nothing.
What?
Pop is void, right? Can you pop an empty stack?
No.
No, so return nothing. You're not. Void doesn't return anything, so just don't do anything.
Okay.
She doesn't think it.
You don't do anything.
You tell the machine not to do anything.
It just does it.
just does it.
It just does nothing.
What?
Hold on. Let's look back at our
Ugh.
interface. Pop, void. So we don't have to return anything. The only time that this sadness would occur is if we tried to do top right now.
Why is pop a void?
Because pop just gets rid of the top element. That's all it does.
I thought in Java we had it where it returned the
Yes.
value that you popped.
This is a different interface.
Okay.
So it just doesn't return anything. It's just like, fine.
Get
Get
rid of
just
that.
with stack, can you have different
Get
data
that
types
out
on
of
the
here.
stack itself?
Yes. Oh, wait, different data types? Yes. Depending on,
How you implement it?
yes. But in general, you have just one. You wouldn't really want more than one. Then you have to do object, you have to do inheritance, casting, blah, 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 blah.
Let's not break things.
Right, it's just more complicated.
Break things.
You want to break things? All right, you go do that for...
What?
Okay. So let's go back to our lovely slide pictures. Or maybe not. So, how do we know if the stack is empty?
If stack top is 0,
How do we know if it's full?
Stack top
if
is
stack
99.
equals the
99.
size.
Equals its size, not 99 because it'd have to go up to 100.
Oh.
If it's 99, there's still that one extra spot left.
Because if there's one
Yes.
item and it
Yes.
is 1, so it's index plus 1.
All right, so push, store an item, increment stack top. Overflow occurs when we try to add a new item to a full stack. What should we do in this case?
Make sure that stack top doesn't equal Emily.
And if it does, we should.
Create a new
Create a
array.
new array
And
that's bigger.
Oh, no.
That's twice the size.
sure, twice the size, then.
And copy all the elements over to that array.
Okay.
Yeah.
And you can definitely do this implementation if you choose for the lab. Huh?
You should definitely show us how to do that.
We've already done that.
It's not hard.
Well, I know we've done that in
You
Java.
create a new array and you do the for loop to.
So yeah, here's, they pushed 5 elements. Which 5, what was the order of pushing here?
Push
What got pushed first?
S.
Then,
U.
all right, someone besides Caitlin, Sydney.
That third, whatever that's, they can't see it.
And all right, we're gonna do it wherever, you have to be a different person each time. So Eric said N is the third one, correct? About the fourth one? N, all right, and the fifth one?
Why?
There we go, Y, thank you.
Wow, class participation.
Yeah, we gotta get class participation going. Okay.
You may not already.
Oh, here's a top operation. So, oh, they assert that the stack top's not equal to 0. Why would they do that?
That's dumb.
Actually, read the comment on the side. So-
It'll terminate the program if it's
Yeah, so that would
not
be.
equal weight.
So, if stack is empty, terminate the program. It's kind of mean, but all right. Return the element of the stack indicated by stack top -1 to get the actual top element. Okay, cool.
Wait.
Hold on, I'm confused. If it's not equal to 0, it stops the program.
Right.
But
No,
then
no,
how
you
can
no,
I-
no, 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 other way around. If you assert that stack top's not equal to 0,
Oh,
so if stack
I
top
was
is
thinking
0,
not.
then it stops the program.
Then, okay.
How would you just say
Never
if
mind.
stack top equals 0 return?
What would you return?
This stack top.
You can't return null. Yeah, in Java you
You
can
have to
return null.
check.
Isn't that nice in Java? But in C++, that's not necessarily the case.
Jump, you can do it. C++. Nah.
So do you have
You
to
could do
assert-
it that way in C++, but
do
it
you
gets
have to do
hairier.
it by using assert specifically?
You don't have to use asserts. You could just call exit, passing 1 in, and now your program's gone.
Or could you
No.
could you even do like a for loop and just do break or something in it too? Not a for loop, an if loop.
Great.
How would you do it if you know it?
No, an if.
Oh, if loop?
Yeah, if you do like if stack top not equals 0.
No, if stop equals 0.
If stack top
yeah,
equals 0,
if stack top equals 0, break. And
What
then
would we
just
break?
Out of function.
no, I wouldn't get out of the function. You still have to
Okay.
return something.
Never mind.
Yeah, so here we just stop the program.
And you can't return null.
Not in this case. Why can't we return null here?
Top.
Because we're returning an actual value. If we were returning a pointer to a value, then we could return null. But here we're actually returning the value.
So just make it a blue.
Make it a boolean. All right, let's see. Pop. It's not empty. You decrement stack top. We said that. Otherwise, you see out. We can't remove from an empty stack, and we just keep going because we actually don't care. That's called underflow. You get it?
No.
So underflow happens when you run under the stack. Overflow occurs when you go past or over the stack.
No.
All right. Don't worry, it'll get even more confusing. Yes.
2 questions.
All right.
First, can you basically use that as a buffer overflow attack? And the second one is underflow, meaning like flow from progressive. She named that.
Second one, probably not. The first one, it depends on the situation.
Okay.
All right, so pop. Did they pop? Oh, they popped something. Oh, notice that they're popping from here, so the stack elements just decreases by 3. The D is still on the stack, and that's perfectly fine because we're just going to override it the next time we push something.
Yes.
Copy a stack. Oh, so we delete our list, we get the size, get the elements, and then we copy everything over.
Why did they delete the list?
Why did they delete the list?
Well,
That is a-
why did they delete that first?
Why did they delete their internal list first? Why would they do that?
I thought you needed
So
to
the-
copy it over.
Right, but what if that list isn't the same size as the new list? What if
How do
you,
you get the values if you deleted it?
but you're deleting your own list, which you're copying into, not copying from.
What's the difference?
Yeah, copy stack. So we're going to copy the stack passed in to ourself. So from this guy to ourself.
Because the other stack.
Oh.
So we delete our internal list because it's useless. We're going to overwrite it. We get our max stack size and top from the new list. We allocate the appropriate amount of memory to match the size of the other stack's stack. Then we copy all the elements in.
I thought we were taking the max stack and multiplying it by 2. The size.
That's if we're expanding capacity. Here we're copying the stack over.
Oh.
Yeah, cheese man.
Wow.
Ouch.
Tough friendship.
She's very
The
good.
D, or the constructor and the destructor.
Oh no.
So the constructor sets the stack size to the parameter value, the parameter value. and stack top to 0, and then creates an array to store all the elements. All right, and the destructor just deallocates the memory, set stack top to 0.
Sure.
I know.
Any questions on that? Why we do that? No? Good.
No memory links.
No memory limits. Copy constructor, basically you're just copying a stack object over. Copies the values of member variables from an actual parameter to formal parameter. Right.
Isn't that what we just did?
Yeah, that's what we just did. Just now it's a constructor. You could overload the equal operator.
No, that's not.
I agree with what Caitlin said 100%. But this is C++, so you'll have to deal with it.
Oh.
Deal with
We
what?
don't have to ever do it.
No, we just have to deal with it.
I don't want that. I could have just overloaded the last one.
Yeah. I don't like operator overload, so we do it once and I call it a day.
Sounds good.
So we basically have one stack equal to another stack. That literally, first make sure you're not setting yourself equal to yourself. And if you're not, copy everything over and then return yourself. That's all it does.
How come you don't like overloading operators?
Because it confuses the code. It makes it harder to read.
Really?
It's dumb.
You like clean code?
I like code that can be read.
Do you like Python then?
Yeah, Python's fine.
I like Python. It's fun.
More of, remember, it's not the language, it's what people do to it.
You can talk about JavaScript.
Why do you always bring that up?
It's my gold language.
All right, stack it. Okay, enough of this. All right, linked implementation of stacks. What would be the advantage of using a linked implementation, aka a linked list?
Less memory? Less memory?
Possibly less memory, right?
You can pull things from the middle.
Pull things from, but we don't do that with the stack. We only operate on the top.
Yeah.
Feels like it's more organized.
More organized.
Oh.
It's more organized.
All right, you know what? Let's do some examples on the board.
Be like all over the place.
Like I just drew it. What? What'd you say?
Linked lists can be like all over the place.
Totally.
Wouldn't that be
That's
less
the beauty of it.
organized?
Wouldn't that, yeah,
Organized
it
chaos.
depends, right?
Yes.
It would be easier to expand too, right?
Easier to expand. Why?
So you just add a node.
Yeah, you just add a node, so it's actually easier in that regard. Yes.
Is it easier to implement a linked list or a map?
Is it
An array?
easier to implement a linked list for a map?
Possibly.
It depends. Depends what you're trying to do. If you're thinking of Project 1, no.
No.
All right. So we have our linked list. We're having a stack. What do we need?
A counter
A counter. Okay.
for the stack itself.
Memory location of the first one.
So the head and a tail. All right. That's actually all we need.
Nothing else?
All right. You can keep size. Sure. I like to call it Lin. Or Lin. All right. What should head and tail point to when we begin?
No.
No.
That's a really dark one.
It's nice and dark. I love it. We need more of these.
Like my soul.
What's the link?
Like my soul.
What?
You walked right into that one.
What's the link gonna be?
0.
Thank you.
Oh, okay. That was
Like my soul.
oh, you actually heard it.
Oh, I heard it. Oh, I heard it. I liked it. That's why I laughed. All right, so we're pushing 15. What do we need to do? It's a linked list, so the first thing we need to do is
Create a node.
create a node. Let's create a node.
Oh, I don't know.
15, and it's going to point to
No.
Five.
no.
Oh no. Okay.
All right. And what do we do anything inside of in the stack?
And the
Increment.
length from 0 to 1.
All right. Increment the length to 1.
Change mtail.
To point 15.
To point to the node, not 15,
Yeah,
but the node.
sorry.
Okay. And then mhead. Anything
Points
we?
to the node as well.
All right. Okay. All right. Now here's where it gets slightly tricky. Pushing 12. What's the first thing we do?
Create another node.
Create another node. I'll put it on top. Okay. What does it point to?
No.
No.
And then you replace the tail and you point it to the 12.
No,
Alright.
first you have to link the 15 and the 12. So the 15 no longer points to
Oh,
null.
wait.
That's what he's saying. Right. So,
He was talking about the head.
right, but that head is pointing to 15. So go to head. I'm going to tell you right now it's head. Have head point to the 12. And then here's the tricky part. Well, two more things.
Increment the length.
Increment the length, that's the easy part.
Change mtail to 12.
Do you want mtail or mhead?
Mhead.
Mhead.
It's a stack. So
It's a
the
stack.
top.
Yeah.
You always want the top to be mhead.
Right.
I was wondering why you were pointing towards the tail.
So there, mhead's now going to point up to the 12. Okay. Now let's go back to the, let's push 15. I just realized I wrote 15 and I meant 5.
Oh.
So we'll fix that.
Operator.
There we go. Man, that was an easy fix.
Woo.
Whoo! So what's the
Oh,
first
you
thing we
gotta
do?
Change your top next. Too.
Create the node.
Create the node.
Add the tail point.
Whoa, whoa, whoa. With 5, it points to
No.
null. Okay.
And then you point from the 12 to the 5.
All right.
which
Well,
is the
how
head.
do we get to the 12? Someone besides
Mhead.
Craig. M.
Head.
Mhead next points to our new node. Okay. Then
Have mhead point to it. And
have
increment
mhead
M
point to the
length.
new node. Okay. Then
Increment M length.
increment m length. Okay.
Now you gotta fix what top does.
Right.
8.
So how do we get the top?
Return the head.
Mhead dot data value, right?
Yeah.
Mhead's data value. So you just go from mhead to its data value. All right, great.
Magic.
All right. How about pop? What does pop do?
You.
Gets rid of the 5.
Right. How do we get rid of the 5?
Change mhead to the other one.
Yeah. Change mhead to the other one.
And then
Have
Make
it
12 point to null.
Mm-hmm. That's the point to null.
And then have M length decrement.
M length decrement. You're missing one final thing.
Erase the arrow from 12 to 5.
I did. Sure. There you go.
Erase the node.
Erase the node. We need to delete the node.
Okay, we can delete the nodes because with the
'Cause
array
it's
we
an-
couldn't delete it because it was inside of the array, but the linked list it's just node point to
Node.
a node.
Right. You got it.
So we can delete the nodes.
You got it.
Okay.
Did everyone get that?
How do you write how to delete? Like do you just write like delete like that?
Delete
node?
space the node.
Okay.
Oh, that's it?
Yeah.
Okay.
We're not trying to be tricky here.
I don't know about that.
All right. We're gonna push the 25. What happens?
Create the node.
Someone besides Craig start talking.
What does it say?
25
null.
point. What's the
Null.
pointer?
Oh.
Null. All right. Then
Have M head point to 25.
so have mhead point to the 25.
After doing that.
Then
Have M head point to 25. Increment M length.
Magic.
Dun, dun, dun,
We can count to 3.
dun.
I am so glad. All right. How's pop work?
I mean, look at
Someone besides Craig, Caitlin, and Sydney.
Make it in head point to 12. And then also get rid of the other arrow.
Have this arrow point to
No.
null.
And then get rid of that.
Get rid of
The node.
the 25 node, right? And then
And do the same thing.
Decrement and like. Speak yourself.
Decrement and length.
All right. Someone else?
Am I allowed to talk?
No.
Oh.
We don't count as people in
That
it.
actually happened.
Make M head point to 15.
Make M head point to 15.
And then that node points to null.
That point node points to null.
Delete the old node and decrements and length.
All right. Final pop. Someone else. Bueller.
Make M head and M tail point to null.
Sure. All right. Okay.
And you decrement M length.
And
And you'd erase the node.
all right. What happens here? Nothing. Yep. All right.
No sadness.
Any questions? Nope.
Your arrow is really weird.
Thank you.
Well, it goes like down and then just.
All right, so they have a stack with a stack top and a bunch of things pointing to it. All right, great. All right, hold on a second. I'm going to speed through these slides
Yay.
because we did all this.
Blah, 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 blah.
Ah, what is postfix?
Oh, postfix is awesome. Have we done post? Have you ever done reverse Polish notation?
Reverse Polish quotation.
Notation.
Quotation.
No?
No.
No.
Oh.
Definitely no.
Is that when Poland invades the country instead of them being invaded?
Ouch. That was good though, but ouch. Wow. All right. Woo. Okay.
Sorry, Poland.
It's okay, Paulette.
Oh, you're racing your lovely push-up balls.
So, are you familiar with infix, prefix, and postfix?
Nope.
All right, let's give you some examples.
Prefix, postfix. Isn't that just basically incrementing and de-incrementing?
No, that's pre-increment, post-increment. So this is infix notation. All right. Actually, let me make this a nice giant table. Infix, prefix, postfix. So if you have A plus B, the prefix means, infix means your operator's in the middle. It's infixed. Prefix means your operator's at the beginning. It's prefixed. So it would be plus AB. Says the same thing. Okay? Postfix,
Is it what?
after it.
Okay.
Okay?
All right.
All right. Let's take you to the next level. So let's do A plus B times C.
Uh-oh. Will you do plus times ABC?
No.
No.
What operator's done? Well, hold on. This is where it gets a little tricky.
Oh, the first one, so it'd be times plus BCA?
What's the first? What operator is going to go first? What operator is going to go last?
Multiplication.
The
Multiplication goes first.
Multiplication goes first. So there's actually different ways to write this. So that means addition's going last. So that's your last operator.
So would you do like plus A and then star BC?
Now it'd be plus B. Well, there's different ways to do this. And depending on how you wish to push. Let's see. Actually, I think I did this backwards.
Yep.
I did do this backwards. Yeah, prefix is confusing. Because it'd be plus multiplication B, C, A.
I said that.
You did.
Thank you.
What would be postfix?
What would be data structures like without Caitlin and Sydney?
Dull.
Sad.
All right, postfix.
A ABC.
B,
Plus?
C
Oh, BC.
times A plus.
Whoa.
What?
I don't like
Exactly like what I was.
You put B, C, multiplication, you're going to do that first. A plus, you're going to take the answer to that, add A plus it.
Oh, it's by order of precedence?
No, it's not ordered by precedence. That's the biggest trick here. Infix has precedence ordering. Postfix does not.
I don't like Sadness has a curse.
Yeah, it makes it the easiest to read.
It's only the easiest to read because you're used to it. Postfix is actually far easier to understand, in my opinion. If you're just now learning it, postfix is way easier because there's no order of operations. You don't have to do the whole "please excuse my dear Aunt Sally" or whatever you have to.
Oh, wow.
Yeah, that's gone. There's no need for it.
Because the compiler does it for you?
No, because you fixed it by the order of operations. In other words, this right here, there's only one way to compute this. You go B, C, multiplication. All right, you're multiplying B and C. And then you take that answer, you have A, and then you add plus. So whatever that answer is, plus A plus that, that's all you can do. That's it. There's no other ordering to this.
That's great.
Over here, the question is, do I add first or do I multiply first? Because it's infix. Over here, the order is fixed. There is no...
More of an education question. How can we all learn postfix?
Because, I don't actually know. So AB with parentheses times C. Forget prefix. I don't care anymore. What would be in postfix?
A plus B.
A.
Or A B plus sign C multiplication sign.
Are there any parentheses?
No.
No.
It's a beautiful thing.
There's no parentheses.
This makes math so much easier.
All right.
When you multiply them,
So, hang on a second. What data structure do you think we use for this?
No data structure.
Let's do this. Let's put an A on the stack. Let's put a B on the stack. And let's put multiplication on the stack. Once we see an operation, we pop the 3 and do it. Okay? So we pop, once we see these 3, we pop it, and we have whatever A times B is, and then we're going to push C, and then we're going to, oh, I did that backwards. We're pushing plus, I'm sorry. Pushing plus, and then we'll finally push multiplication. We have an operator and 2 things below it, so we pop all 3 of it, and then you finally get the answer, A plus B times C. You'll see?
Isn't that how the first calculators worked?
Yes, this is how calculators worked.
I thought
World.
calculators
Wait,
work by
did you
taking
say
the
work?
logs of 2 numbers.
The what?
The logs of 2 numbers.
Where did that come from?
From a physics professor.
From physics, take the logs of 2 numbers. Okay, why would they take the logs of 2 numbers?
The logarithm.
I mean, yeah, there's logarithms involved, but you can do that with postfix as well. Now let's see if I taught that backwards.
Oh, I hope you didn't.
No, I didn't. Oh yeah, see, there is actually another way to do it.
Oh.
Ooh, this is beautiful.
No, there's not.
No. So there is actually different ways to type it out. I did that way. Another way to do A plus B times C is actually A, B, C. Let me try that again.
Really bad.
Huh?
Your A does not look very good. What? It was like all
ABC.
weird and smushed and
Everybody's a critic.
when it comes to writing on the board, we have to watch out for the online stream.
That's true. So we put A, B, C, and then we put a multiplication on it. What do? We pop the top 3 elements, multiplication C and B, and then we put the answer on the stack. And then you add plus, another operator, you pop the top 3, and then you put that answer on the stack. That is a triangle. That's okay.
Okay, so
Well, that's nice and small.
Yep.
And I think I just got these two backwards, by the way. I think it's actually, this is prefix, that's postfix, but whatever. Sorry about that.
Are we ever
Wait.
going to need this again?
No.
wait, okay, so does that
Oh,
mean-
good, we have examples.
Oh, yay.
Oh, I did do it right. No, I got the terms right. Yes.
Okay.
So a plus b equals ab plus, a plus b star, abc, multiplication because you're multiplying the bc and then you're adding the result to a multiplied by b plus c, ab star, look, you can put the star there, and then c plus. And then notice those parentheses, totally get rid of the parentheses, don't need them. And now if you have this, notice the parentheses are forcing the operations. So this is actually cool how this works. Because it does A, B minus, so it forces to do the minus first, put that on the stack. Then it's C, D on the stack, put a plus, so it's going to add the C and D on the stack, return the result. So your two results are the subtraction of A and B and C and D. Those are the two things on the stack, and then you multiply it. Y'all see that, or would you like me to write that on the board for you?
I have one question.
Huh? I had everyone spoke at once. You're good?
One question. Okay.
For the rest
So
of the
with-
course.
With the one, with all of them that have like 3 variables or more,
Mm-hmm.
is it basically when you're writing the postfix, it goes where you like you can kind of, I mean, you list them in order kind of, but then it's like once you reach an operator, it does the 2 in front of the operator. So then like that creates like a new one. So like with the ABC times plus,
Mm-hmm.
so it goes okay. Well, here's a times, so we put in CB.
Right. You take
And
the
then
previous two.
that becomes itself, and then you go, oh, here's the plus sign, so let's go to the BC times and add it to the A.
Correct. You got
Okay.
it. That's exactly what's going on.
Okay, just checking.
The beauty of this, there's no need for parentheses or order of operations. What's that?
That was modest. I said we're geniuses.
Geniuses. All right, and this is how old calculators worked. Because otherwise you have to develop expression trees to figure out how to parse infix, which takes a lot more computation power.
That doesn't sound like fun stuff.
It's fun, but you can't just do it with this. Well, maybe you can. That's a great project idea. Thank you.
No.
Thank you, Caitlin. That's a beautiful project
Good
idea.
going,
We'll do
Caitlin.
expressions using stacks. That was awesome.
Oh, a senior project?
Sorry, that was good. I liked it. All right. So a lot of cat compilers, I don't know why it says many. All old compilers translate the arithmetic expressions into postfix notation and translate this into a machine code. We just use expression trees.
I like that many.
Many, yeah, whatever.
Oh.
Scan expression from left to right whenever an operator found, back up to get the operand, perform the operation, and continue.
Probably many because the person. didn't-
Oh, here, we got more pictures.
Yay.
Pictures.
So 6, 3, 6, 3. The plus goes on, so we pop twice. 6 plus 3 is 9. Push the 9 back on the stack. You see how that happened?
Yes.
6, 3, now become the 9. Push the 2, have a multiplication. Pop it, you now have the 18. And in the old school, when you do equals, it just pops the last value on the stack and gives it back to you, which would be 18. Everyone good with this?
Yep.
All right. So multiplication, or I'm sorry, plus, minus, multiplication, division have two operands. If the symbol's plus, just pop it, and if the symbol's anything else, it's an error. Ooh, assume postfix expressions are in the form #3. What is this? The symbol scanned in is pound, the next input is a number, the symbol scanned is then, oh. So they're going through an example. We don't care about this. We don't want that. All right. I'm going to stop right here because we have a recording.